Oumuamua 2 has truly arrived. On July 1st, 2025, astronomers discovered another mysterious celestial object, following Oumuamua. Just as the world was still lamenting the missed opportunity with Oumuamua, this new, even more powerful interstellar visitor has already entered our solar system at high speed. Astronomers quickly mobilized, and this mysterious visitor is faster, possibly larger, and on an even more extreme trajectory. Is it yet another natural wonder from the depths of the universe? Or, as some bold speculations suggest, an interstellar spacecraft? This time, the world's most advanced telescopes, including the James Webb Space Telescope, have all turned their gaze, firmly locked onto this unexpected guest. Humanity's close encounter with the latest interstellar visitor has officially begun. Today, we'll examine the latest observational data from scientists to determine whether this object, playfully dubbed Oumuamua 2, is just a lonely rock, or something beyond our expectations. Most crucially, can it solve the mysteries left by Oumuamua? Back in 2017, astronomers discovered something extraordinary. An interstellar object later named Oumuamua entered our solar system. It was incredibly fast and oddly shaped, completely defying expectations. 2 years later, the arrival of a second interstellar object, Comet 2 I/Borisov, confirmed that Oumuamua was no fluke. Now, in 2025, the same story unfolds again. A new object has appeared on our radar, designated as A11P1I3Z. Back then, Oumuamua flew past Earth, and we only realized 5 days later. But this time, we're prepared. This object was first detected on July 1st, 2025, and catalogued by the Minor Planet Center of the International Astronomical Union. Its appearance immediately caused a stir in the astronomical community. Initially, it appeared on the Near-Earth Object Confirmation page, marked for further tracking. But this is no ordinary rock. On a long elliptical orbit, as astronomers began calculating its trajectory, all signs clearly indicated this visitor isn't from around here. Its path is a distinctly hyperbolic curve, meaning it isn't bound by the sun's gravity, the defining characteristic of an interstellar object. Preliminary calculations show its orbital eccentricity is around 6, the highest ever recorded for any passing object in our solar system, confirming many initial suspicions. This object isn't just interstellar. It's traveling along one of the most extreme interstellar paths we've ever seen. Consider this: an object moving faster than 42 kilometers per second. The minimum speed needed to escape the sun's gravity is considered interstellar. This newcomer approaches the sun at about 66 kilometers per second, far exceeding the solar system's escape velocity. But to confirm its path definitively, astronomers need more data. Shortly after its discovery, archival data from the Atlas survey revealed earlier images dating back to June 25th. With these new data points, astronomers could refine the orbital calculations. All evidence continues to strongly suggest A11P1I3Z is indeed an interstellar visitor, now officially designated by the Minor Planet Center as 3I/Atlas, the third confirmed interstellar object in our solar system. From its trajectory, we know 3I/Atlas will reach its closest approach to the sun on October 27, 2025, at about 1.4 astronomical units. Unfortunately, Earth will be on the opposite side of the sun then. But fortunately, its closest approach to Earth will be on December 17th, at 2.4 astronomical units. Far enough to pose no danger, but close enough for detailed observation, allowing our telescopes to observe it properly. After that, it will continue its outward journey. Around March 10, 2026, it will pass near Jupiter's orbit. Early images taken by astronomers show this object has an apparent magnitude of about 18.8, based on its brightness. If its albedo is typical, then this object could be around 20 kilometers in diameter, much larger than Oumuamua, even bigger than 2I/Borisov. Of course, it might also be more reflective, or even emitting gas. These factors could skew size estimates. But here's where it gets really interesting. If this object starts exhibiting any non-gravitational acceleration, like what we observed with Oumuamua, that would open up a whole new field of study. This acceleration could be caused by gas emission, or in some bolder theories, it might be due to some artificial propulsion system. That's precisely why all eyes are now on the James Webb Space Telescope. With its powerful infrared detection capabilities, Webb can capture this object's thermal radiation, revealing its temperature, size, and possibly even its shape. Another striking feature is this object's orbital inclination of nearly 175 degrees. Such an extreme angle almost guarantees it's not native to our solar system. In fact, its trajectory suggests it likely originated from the galactic stellar disk, the flattened plane of our galaxy, where most stars reside. This leads to a tantalizing idea. If we can precisely determine its incoming speed and direction, we might trace it back to its true home, the star system where it originated. Interstellar visitors like Oumuamua used to be once-in-a-century events. Now they're appearing within just a few years, making us realize These events might be more common than we thought, but each encounter is fleeting. How can we avoid missing them? How can we turn these rare encounters into routine scientific study? To answer this, we must look back at that Oumuamua, like a ghost streaking across the night sky. It was absurdly fast. By the time we reacted, it had vanished forever into deep space. We only caught a few glimpses, but it left humanity with three still unanswered mysteries. First, its bizarre shape. From its brightness variations, astronomers deduced Oumuamua was no ordinary sphere or potato-shaped rock, either cigar-like or pancake-flat, with an aspect ratio up to 10:1, tumbling chaotically through space. Neither shape has been seen in our solar system. Second, its utter silence. Webb's predecessor, the Spitzer Space Telescope, stared relentlessly for 30 hours, trying to detect any thermal signature. Result: complete silence. No heat, no reflection. Its surface like cosmic charcoal, baked by eons of radiation. Not a comet. It emitted no gas or dust, not even a wisp of a tail. But all this pales compared to its most baffling trait, that eerie acceleration after passing the sun. It should have slowed under solar gravity, but Oumuamua didn't. It sped up, exhibiting clear non-gravitational acceleration, like a car coasting uphill without power, defying physics. Where did this mysterious thrust originate? This sparked science's great debate between natural origin proponents. They tried all sorts of far-fetched explanations. For example, it might be a hydrogen iceberg, gaining thrust by evaporating hydrogen we can't see. But this theory was quickly disproven, because a hydrogen iceberg couldn't possibly remain intact during the long interstellar journey.